Right, hi everybody. This is the Math 31 optimization review. This is question 1. Well, 1I, I suppose is the best way to say it here. Okay, so what we got to do with this question right here, a few things. First of all, what we want to do is find the critical numbers. Okay? Now, the critical numbers are places where the first derivative is either undefined or that goes to 0. But whichever one it is here, they still have to be in the domain of the function. So one of the first things we got to do is make sure we understand the domain of the function here. And because it's just a basic polynomial, this is all reals. So to find the critical number here, it's simply a matter of taking the first derivative, which in this case will be 4x cubed minus 64x. And then what we got to do here is, we know that this is going to be undefined nowhere, so we're just going to set it equal to 0. And then, I can see right here there's a common 4x to both of those terms. So then I'll get an x squared minus 16 coming out of that, equal to 0. And to solve this is actually fairly straightforward here. Either x is going to equal 0, or x is going to equal plus or minus 4. Okay, but these are all my critical numbers. Okay, these are my critical numbers here, 4 and plus or minus 4. The next thing we've got to do here is determine the intervals of increase and decrease. Now that's actually fairly easy to do. If you think back to the pre-calculus chapter exam, we've already dealt with that. What I need here is, I need the first derivative. I need to know where the first derivative is either positive or negative, okay? Because that will correspond to where the function is increasing or decreasing. So in factored form, okay, we might look at this as the first derivative is going to be 4x, and then I can go even further here. That'll be x minus. Sorry, I wanted to say 2 here, but that's not true. It's x minus 4, x plus 4. Sorry, x plus 4. I did it again. I don't know why I'm having a hard time writing that. X plus 4. And this is our first derivative. Okay. Now what we notice about the first derivative is that it's a cubic, and we've got zeros at 0, negative 4, and 4. Okay, which means according to our number line right here, if we write these out, we're going to get negative 4, 0, and 4. Okay, I know that this is going to be a cubic with a positive leading coefficient, meaning that if I was to give this a very, very rough sketch, I still know that it's going to be going up, and so it's got to cross through those, and each of those factors has a multiplicity of 1, so it has to look something like that. I don't know exactly how it looks, but it's got to have that rough idea to it. Now, we want to figure out the intervals of increase and decrease. Well, those correspond to where the derivative is above the x-axis or below the x-axis. So it's below here. Okay, it's above in this little pocket right here. It's below in this little pocket and above over here. So then we could write down here an interval notation. This thing is increasing, okay, on the interval negative 4 to 0 and then 4 to infinity. And it's going to be decreasing on negative infinity out to negative 4, okay, union 0 to 4. Okay, so those are our intervals of increasing and decreasing. Now the question asks to determine the coordinates of the maximum and minimum points. Well, I can take a quick look here. I can see that our function is decreasing and then increasing to negative 4. So this is going to make this automatically a minimum. Then it increases and decreases, which is going to make this point here a maximum, and then decreases and increases, so this is going to make this one again a minimum. So now I might go up here. Now remember, to figure out what the coordinates are, what I got to do is I got to go back to the original function. So we're going to determine the original function evaluated at let's say negative 4. Okay, the original now not the derivative. Okay, the derivative only gives us the slopes. The original function is what gives us the y coordinates. So this will end up being negative 4 to the 4th minus 32 times 4 squared minus 5. I'm beginning to wish I had my calculator at this point here. So anyway, this is going to be negative 4 to the 4th here. This is going to be oh shoot, that's going to be, well, that's the same as, I should just do it this way. This is going to be the same as 2 squared, so 2 to the 8th. 2 to the 8th is going to be 256. 4 squared. This is going to be 2 squared, so this is 2 to the 4th. Minus, well, this is 2 to the 5th, this is going to be 2 to the 9th, so this is going to be minus 5 12 minus 5. So altogether, this is going to be 256 minus 512 will be negative 256 minus 5 is going to be minus 261. Okay, and we know, therefore, that this point right here, negative 4, negative 261, is going to be a minimum. Okay, now, the next thing we got to do is we got to figure out what's going to happen at 0. Now, we already know that 0 is going to correspond to a maximum, and we plug this in. This is really easy. This is 0 to the 4th minus 32 times 0 squared minus 5. Well, that's phenomenal. It's just minus 5, which means the point here, 0, so therefore 0 comma negative 5 is going to be a max. Okay, and then lastly, we need to figure out what's going on here at positive 4. And once again, I am really wishing I had my calculator just to verify this, although because I've got even exponents here, that work that I'm doing here is gonna mirror what was going on here. So I already know there's a little bit of symmetry going on here. This is going to end up being negative 261, assuming I did that calculation correct. And so therefore we're going to have the point 4 comma negative 261, and just like before, this is going to be a minimum. And that's all the information this question is asking me to create.